Hey everyone, what's up? In this video, we build the backend for a secure MCP app. MCP stands for Model Context Protocol. It's a way for apps and agents to call tools in a standard way. We use Descope for sign-in and for controlling who can do what. Let us jump right into the demo. First, let us log in using Descope Auth. I will use my email to sign in, and just like that, we are authenticated. Behind the scenes, our app is now validating that session using our backend route. The green check mark tells us the session is valid and secure. Now, we need to define what our agent is allowed to do. We are going to select our dynamic client registration scopes or requested scopes. For this demo, let us go ahead and select them all: MCP:read, MCP:write, MCP:admin, and MCP:connections. With those selected, we hit the Register Agent DCR button. This talks to our API, creates that unique identity in the scope, and saves it to our local store. Next, we hit Exchange Token, and now we have a short-lived high-privilege JWT to make our tool calls. Let us put it to the test. I'm going to select the red_database tool and hit execute. Look at that. We can see our JSON RPC transport working in real time. On the left-hand side, you can see the clean request we sent, and on the right-hand side, there is our response containing the actual data from our local database file. We can keep going. Let us try to list _tables. There they are: users, orders, and products, all mapped out with their row counts. We can even do more advanced stuff like inserting a new record, deleting one, or even running a raw query using the admin scope we granted earlier. If we jump over to the Descope dashboard, we can see exactly what is happening under the hood. In the user section, we can see the profiles of everyone who has connected to our application. Every single action we just took is being tracked and secured by the logic we wrote. You'll learn how to implement Dynamic Client Registration (DCR) to verify agents on the fly, use role-based access control (RBAC) to enforce the principle of least privilege, and leverage Descope connections to securely fetch data from third-party API is like GitHub without managing complex OAuth flows yourself. It's all about giving your agents the tools they need while keeping your data under a lock and key that you control. The front end is already done. You get a starter app, you sign in with Descope, you pick your scopes, you hit Register Agent, then Exchange Token, and then you can run tools. The backend checks your token and your scopes every time. We only write the backend in this video, the API routes and the data, so you can follow along and test as we go. Let's get started. First, we need to grab our starter files. Let us head over to the GitHub page and find the Fast MCP Starter repo. We will click the green button to get our clone URL. Now, let us jump into the terminal. We will type git clone, paste that URL, and add a period at the end to tell Git to install it right here in our current directory. Once those files are in, let us run npm install to bring in all our dependencies. If we open up the package.json file, we can see what we are working with. We have the Descope Next.js SDK, which is our bridge to the authentication server. We have UUID for generating unique identifiers for our agents. For the UI, we are using Framer Motion for those smooth animations and Lucid React for our icons. And of course, we are running on the latest versions of Next.js and React. Before we write any code, we need to set up our environment. Let us create a .env file in the root. We need 3 keys here: next_public_descope_project underscore ID, Descope underscore management underscore key, and MCP underscore service underscore key. To get your project ID, head over to the Descope website and sign up using your email. Upon signing up, you will be taken to this dashboard. Over here, you can choose the method you want to use for MFA and set it up. On the right hand side, you will see the welcome and login interface that will be available inside our application once we complete the setup. For now, you can try logging in here to receive your authentication response and JWT. Also on the right hand side, under the front-end integration section, you will notice a project ID at the top of the auth provider. Let's copy that because this is going to be the project ID we use for our application. Next, we need the management key. Navigate to company settings, then click on the management keys tab, click create, name it Fast MCP, and make sure to grant it full access roles before hitting create. Copy that key and paste it as your management key. Finally, for the MCP service key, jump back into your terminal and run the command open /SSL rand-hex32. This gives us a secure random string we can use to sign our requests. Now we are ready to build. Let us open the app folder, then API, then auth, and open the root.ts file. Let us clear out the placeholder code and start fresh. First, we need to bring in our tools. We will type import next request, next response from next/server. These are the standard request and response objects for Next.js. Next, let us add import open curly brace v4 as UID v4 from UID quote semicolon. We will use this to create unique client IDs for every agent that registers. Now for the security layer, import create SDK from Descope/Next.js-SDK/server. This gives us the backend tools to talk to Descope and check if a user is actually logged in. Finally, we need a way to save our registrations. Import get DCR record put DCR record from lib/mcpdcr store semicolon. Now, we actually have not created that store yet, so let us go ahead and do that now so our imports do not break. Inside the root directory, create a new folder called lib, and inside that, create a file named mcpdcrstore.ts. In this file, we are building a simple in-memory database to keep track of our registered agents. Let us start by defining the shape of our data. We will type dcr record equals open curly brace client id colon string owner sub colon string granted scopes colon string array access key colon string registered at colon string. This record stores everything we need: the client ID, the user who owns it, their permissions, and the access key. Now, let us create the actual storage using a JavaScript map. Const records equals new map less than string, dcr record, open paren, close paren, semicolon. To make searching easier, let us create a helper function to generate a unique key. We will type function make key open paren owner subcolon string, client id colon string, close paren, colon string, open curly brace, return backtick, $, open curly brace, owner sub, client ID close curly brace. This just combines the owner and the client ID into a single string. Now let us add the functions to save and retrieve these records. First, to save, export function, put DCR record open, parent record colon, DCR record, close parent colon void, open curly brace records dot set open parent, make key open parent record dot owner, sub record dot client, ID close parent record, and finally a function to fetch a record when we need to verify a token export function get DCR record owner subcolon string, comma client ID colon string, close parent colon DCR record, or undefined open curly brace, return records dot get open parent make, key open parent owner, sub comma client ID, and there we go. We have our storage logic ready. This simple map acts as our source of truth for every agent registered in our system. In this video, we have set up our environment, cloned our starter, and built the foundation for our agent registration store. In the next section, we will jump back into the API route to handle the actual registration logic and talk to the Descope SDK. Now that we have our storage initialized, we are going to dive into the heart of our authentication route. I have already laid out the core logic here, so let us walk through these blocks line by line so you understand exactly how our MCP server handles security and token management. First, let us look at how we identify our agents. We have a function called generateClientID. We are using backticks to create a string template, starting with mcp-client-, then we use u8v4.slice, starting from 0 to 12. This gives us a clean, unique identifier for every agent that joins our network. Next, we have a little utility called asStringArray. This is purely for safety. It checks if our input is actually an array. If not, it returns an empty one. If it is, it filters through to make sure every single value is a string. This prevents our app from crashing if someone sends us bad data. Now, this next part is crucial. It is the policy scopes from session function. This is where we decide what a user is actually allowed to do. We pass in the token, grab the permissions and roles using our utility, and then we check them. If you have specific permissions, we return those. Otherwise, we set up a baseline using a new set containing MCP:read and MCP:connections. If your role includes MCP-writer, we add the right permission. If you are an MCP-admin, we give you everything, write and admin access. Finally, we turn that set back into an array. We are going to crop here. To make sure users do not ask for more than they are allowed, we use intersect scopes. It takes what you requested and compares it against what you are allowed to have. It uses a filter to only keep the scopes that exist in the allow set. Now let us move into the actual post handler for our route. First, we pass the request body using await rec.json. We grab the action, client name, and other details. We also check for an XMCP-service key in the headers. This allows us to run in service mode if the keys match, otherwise we default to a standard user session. If we are not in service mode and there is no valid token, we return a 401 error, letting the user know they need to sign in via Descope first. Once we are through the gate, we need to know who is making the request. We set up current sub and current email. If we are in service mode, we use the body data or defaults like service-client. Otherwise, we pull that info straight from the Descope session token. Now we get to the actual logic branches. If the action is register, we first make sure we have a valid owner sub and that our Descope management key is set up in our environment variables. If either is missing, we throw an error. To finalize the registration, we take the requested scopes and run them through our policy check to get the granted scopes. If the result is empty, we return a 403, forbidden, because the user is trying to access things they do not have permission for. If everything looks good, we generate that unique client ID and initialize the Descope SDK using our project ID and management key from the environment. We then call sdk.management.accessKey.create. This creates a real access key in Descope. Notice we are passing in the client ID and our custom metadata, like the owner sub and the granted scopes. This links the Descope key directly to our internal MCP logic. We have to handle potential errors here too. If the Descope SDK returns an error or no clear text key, we return a 500 status and explain that the registration failed. But if it succeeds, we call put DCR record. This saves our new agent into the map we created earlier, storing the client ID, the scopes, and the clear text access key. Finally, we send back a success response with all the details, including a handy Descope console URL, so you can go and see the agent you just created in the dashboard. Now, what happens when an agent wants to actually use a tool? They need to exchange that key for a token. If the action is exchanged as token, we verify the session and make sure a client ID was provided. Just like before, we calculate the policy scopes and the intersection. We then call getDCR record. If we cannot find that client ID for this user, we return a 404, not found. We initialize the SDK again and call SDK.exchangeAccessKey, passing in the key from our storage. This is a secure exchange that happens server to server. From the result, we grab the JWT token and calculate when it expires. Usually, these last for about an hour or 3,600 seconds. Then we return that token to the user. We even provide a token preview, just the first 16 characters, so the front end can show it safely without exposing the whole secret. Sometimes our tools need to talk to other services, like GitHub. For that, we use the get-connection token action. Currently, we only support GitHub. We grab the outbound app ID from our environment. Then we use the SDK to call fetch token by scopes. We tell the scope we need repo and read :org access for this specific user. If that fails, we let the user know, but if it works, we return the manage access token. This is beautiful because we do not have to manage the OAuth flow ourselves. The scope handles the lifecycle of that third-party token for us. We also added an introspect-token action. This is for when you have a token and you just want to see what is inside it. We call sdk.validate JWT and return the decoded payload, including the subject and the scopes. Finally, we have create audit event. Security is not just about blocking access, it is about knowing what happened. We use the management SDK to create an event, logging the action name, the type, like info or error, and the data associated with it. This creates a permanent trail in the Descope audit logs, and at the very end, if the request did not match any of these actions, we return a 400 error for an unknown action. That is the entire authentication flow. We have covered registration, token exchange, third-party connections, and auditing. We are moving right along. Now that we have our main auth route handled, we need a way to verify that a session is actually valid before we let any tools run. This is where the validate session route comes in. I have the logic ready to go, so let us walk through it line by line. First, let us look at our imports at the top of the file. We are bringing in next request and next response from next/server. These are the bread and butter of our API routes. Then we import create SDK from the Descope Next.js-SDK/server package. This is what allows our backend to talk directly to Descope and verify that a token has not been tampered with. Next, we define a simple type called request body. It is an object that expects an optional session token as a string. This helps keep our TypeScript compiler happy. Below that, we have a clean little helper function called JWT preview. JWT tokens can be massive strings, so this function takes that string and, if it is long enough, slices the first 16 characters and the last 8 characters, joining them with dots. This way, we can log or display the token safely without cluttering our screen. Now, let us get into the post function itself. This is an async function that takes our request. We start with a try-catch block to handle any unexpected hiccups. Inside the try, we first pass the body by calling await rec.json. We grab that session token from the body. If the token is missing, we immediately return a 400 error with a message saying missing session token. Security first. Next, we need to make sure our server actually knows which project it belongs to. We pull the project ID from our environment variables. If it is not there, we return a 500 error because the server is not configured correctly. Now we get to the fun part. We initialize our SDK by calling create SDK and passing in our project ID and management key. Once that is ready, we call await SDK.validate session and pass in our session token. This one line is doing a lot of heavy lifting. It checks the signature, the expiration, and the issuer. If everything checks out, we return a success response. We send back OK set to true, our masked token using the JWT preview helper, and the full token payload, so the application knows who the user is. Finally, we have our catch block. If anything goes wrong, maybe the token is expired or fake, we catch the error. We check if it is a standard error instance to get the message. Otherwise, we default to unknown. Descope error. We then return this as a 401 unauthorized response. And that is it. A robust, secure way to validate sessions on the fly. Summary-wise, we have built a dedicated endpoint that takes a session token and verifies it against Descope's security standards, giving our backend the green light to proceed. We are entering the final home stretch of our backend build. This is the big one, the MCP route file. This is where we define our tools, handle database operations, and enforce our security policies. I have got the code sections highlighted, so let us walk through them so you can see how this all connects. First, at the very top, we are pulling in our standard utilities. We have next request and next response for our API, UUIDv4, for generating unique client IDs, and our Descope SDK tools. We are also adding read file and write file from node:/fs/promises along with the path module. This is because we will be interacting with a local JSON file as our database. Now let us define our tools. We have a constant called tools, which is an array of objects. Each object defines a tool's name, description, and importantly, the scope required to use it. First up is the read_database tool. It has a scope of MCP:read and lets users query our data. Next is list_tables. Also mapped to MCP:read, this gives the user a quick overview of what data is available. Then we get into the higher privilege tools. Delete_record requires MCP:admin. We have marked the danger level as high because, well, it deletes data. Even more powerful is run_query. This requires MCP:admin and has a danger level of critical because it executes raw SQL-like logic. Finally, we have fetch_GitHub_issues. This uses the MCP:connection scope and is specifically designed to work with the scope connections. To keep things organized, we have defined some types. Session context stores the user's identity, email, and permissions. DB table record and DB schema define the shape of our local database, which includes users, orders, products, and audit logs. we set our data underscore file path by joining the current working directory with data/db.json. We are also reusing our asString array and intersect scopes helpers here to handle our permission logic cleanly. Now let us look at derive policy scopes. This is the brain of our security. We start with a baseline set containing read and connections. If a user has the MCP writer role, we add write. If they are an MCP admin, we add both write and admin. If the user already has explicit Descope permissions, we use those as the primary source of truth. To bridge the gap between our session and these tools, we have get session context. It awaits the session, grabs the token, and maps it to our session context type. We also have get service context, which handles requests coming from automated services instead of logged in users. For our database work, we have two simple async functions, readdb and writedb. They handle the file system I/O, so we can persist changes to our JSON file. We also have parse table name to ensure nobody tries to access a table that doesn't exist, and Next.id to auto-increment our record IDs. Handling external tokens is next. The get GitHub token function first checks if a token is in our environment variables. If not, it looks for a Descope outbound app ID. It uses the SDK to fetch a fresh token for the specific user with the required scopes, like repo and read colonlog. This keeps our GitHub integration totally secure. To handle raw queries safely, we have run limited query. It uses regular expressions to match simple select statements. For example, it can handle select count asterisk or a basic select asterisk with a limit. If the query doesn't match these safe patterns, it throws an error. To keep track of everything, we have create audit event. This is an async function that sends tool activity straight to Descope's audit log. It is designed to be non-blocking, so even if the audit log is down, our tools still work. The core execution logic lives in execute tool. It records the start time, finds the tool in our array, and immediately checks if the user has the granted scopes. If they don't, it logs a denied audit event and returns an authorization denied error. If they are authorized, we enter a switch statement. For list underscore tables, we read the database and map over the entries to show the table name, row count, and last modified timestamp. For read underscore database, we pass the table, apply any filters the user provided, and return the sliced records. For insert underscore record, we validate the payload, generate a new ID, push it into the array, and save the database. For delete underscore record, we filter the array to remove the specific ID and write the changes back to the file. For run underscore query, we take the raw string and pass it to our run limited query helper. And for fetch underscore GitHub underscore issues, we get the user's token, call the GitHub API, and map the result into a clean format. After the tool runs, we calculate the latency, create an allowed audit event, and return the result. If any of this fails, the catch block logs the error and returns a formatted execution error. Finally, we have our main post handler. It checks the action from the request body. If the action is list underscore tools, it simply returns our tools array. If the action is initialized, it sets up the auth context and calculates the effective scopes the user is allowed to use. It then returns a standard MCP initialization response, including protocol version and server capabilities. If the action is call underscore tool, it validates the user again, calculates the permissions, and passes everything to our execute tool function. It then returns a full JSON RPC response, including the request, the response, and the auth context. And that is our entire backend logic. We have built a fully secure, robust tool server that handles local data and external APIs. To wrap things up, let us quickly summarize what we have done. We have built a Next.js backend that handles identity registration, secure token exchange, and a tool execution environment that follows the model context protocol. Every action is audited, every permission is checked, and we are even bridging into third-party APIs like GitHub, all while keeping our secrets safe with Descope. The very final piece of the puzzle is our data file. Let us create a folder called data and a file inside named db.json. This file acts as our persistent storage. It holds our users, orders, products, and an empty array for audit logs. This simple structure allows our database tools to actually have something to read and write to as we test the application. We have officially completed the backend. Everything from security to storage is now in place. We have the backend running perfectly, and now it is time for the best part, seeing all that hard work in action. We are going to walk through the full life cycle of a secure model context protocol request, from the first login to executing protected database tools. Let us jump right into the demo. Before we jump into the live demo, we need to head back to the Descope dashboard to set up our infrastructure. We are going to configure our agentic identity using the Descope Agentic Identity Hub. This is a dedicated space designed specifically for managing how AI agents and MCP servers interact with your users and data safely. Over on the side menu, click on Agentic Identity Hub to see the drop-down. You will see options for Agentic Identity, MCP servers, connections, and policies. For now, we are focusing on MCP servers. Click that, then click Create MCP Server, and this modal will pop up. We will name our agent Fast MCP and use the same for the description. Now, for the MCP server URL, after you host your app on Vercel, you will have your domain/API/MCP root available. That is the URL you want to paste right here. As we scroll down, you will see the Dynamic Client Registration, or DCR section. This is an optional but powerful feature that allows MCP clients to register themselves automatically with your server if they do not support the standard manual methods. We are going to toggle Enable DCR to On. Now we need to define our MCP scopes. These must match the exact scopes we defined in our codebase. Let us jump back to our MCP route.ts file to make sure we get them right. First is red_database. Copy that name and description from the code and paste it here. Now, we need a connection scope. Connections in the scope are pre-configured OAuth bridges to third-party services like GitHub or Slack, allowing your agent to act on behalf of the user. I'm going to show you how to set up a new connection. In the connections library, search for GitHub. To make this work, we need a client ID and a client secret from GitHub. Head over to your GitHub settings, go to Developer Settings, and click New GitHub App. Once you create it, grab your ID and secret, paste them into the Descope connection settings, and hit Save. Now, we will select User as our connection scope for this tool. We will repeat this process for the rest, list_tables, insert_record, and so on, copying the descriptions from our code and setting the connection scope to user each time. Next, let us look at the flow sections. The user consent flow defines exactly what the user sees when they authenticate. It handles the sign-in and asks the user to approve the permissions the agent is requesting. The client registration flow runs right after an agent registers, allowing you to tag or classify agents, like labeling a specific agent as a sales agent. For our setup, we will select Sign In as the user consent flow and toggle Skip Consent screen to keep the experience smooth. Finally, hit that Create button. Once created, Descope gives you a unique URL to connect your MCP server. You will even see code samples for the Vessel MCP adapter right there. Click Done and there it is. Our Fast _MCP server is live. If you check the side menu again, you can now see your active connections and your server policy. By default, Descope applies a standard policy to keep things secure while you get started. Now that our infrastructure is ready in the cloud, we can finally test the full app. First, let us log in using Descope Auth. You can see the login interface we set up earlier. I will use my email to sign in, and just like that, we are authenticated. Behind the scenes, our app is now validating that session using our backend route. The green check mark tells us the session is valid and secure. Now, we need to define what our agent is allowed to do. We are going to select our dynamic client registration scopes or requested scopes. For this demo, let us go ahead and select them all: MCP:read, MCP:write, MCP:admin, and MCP:connections. With those selected, we hit the Register Agent DCR button. This talks to our API, creates that unique identity in the scope, and saves it to our local store. Next, we hit Exchange Token, and now we have a short-lived high-privilege JWT to make our tool calls. Let us put it to the test. I'm going to select the red_database tool and hit Execute. Look at that. We can see our JSON RPC transport working in real time. On the left-hand side, you can see the clean request we sent, and on the right-hand side, there is our response containing the actual data from our local database file. We can keep going. Let us try to list _tables. There they are: users, orders, and products, all mapped out with their row counts. We can even do more advanced stuff like inserting a new record, deleting one, or even running a raw query using the admin scope we granted earlier. If we jump over to the Descope dashboard, we can see exactly what is happening under the hood. In the Users section, we can see the profiles of everyone who has connected to our application. Every single action we just took is being tracked and secured by the logic we wrote. This has been a quick, high-impact build of a secure model context protocol backend. We have covered everything from dynamic client registration to least privilege tool execution and audit logging. If you want to see us build the Python version of this exact stack, let me know in the comments. Thanks for building with me. See you in the next one.